As we delve deeper and deeper into the quantum realm, we observe weird and strange phenomena. How do these relate to our everyday observations? And what do these mean? Now, there are several interpretations of quantum mechanics, and today in this video, we'll be exploring the most widely accepted and known interpretations of quantum mechanics, the Copenhagen interpretation. The Copenhagen interpretation, developed by giants like Niels Bohr and Werner Heisenberg, provides a framework for understanding this enigmatic world. It offers a way to interpret the results of quantum experiments, to reconcile the theory with our observations, and to understand the role of measurement in shaping the quantum reality. Now, before we delve deeper, let us recap some of the fundamental concepts of quantum mechanics we discussed in our earlier videos. Superposition, a fundamental concept in quantum mechanics, which states that a particle can exist in multiple states simultaneously. And wave-particle duality, which is a fundamental property of particles where particles can behave like waves and waves can behave like particles. These concepts really doesn't seem to have any connection to the reality we perceive in our everyday lives. How do we make sense of this? This is where Copenhagen interpretation comes. The Copenhagen interpretation provides a framework for understanding and interpreting these bizarre concepts. Now, the most central part in the Copenhagen interpretation is the concept of wave function, which is a mathematical tool used to describe the state of a quantum system. Superposition can be understood in the terms of wave function. When a system is in a superposition, wave function represents a combination of different possible states. Now, when we observe a quantum system which exists in a state of superposition, its wave function collapses into one single state. It's just as it chooses one reality from many other possible realities. This collapse is one of the most debated topics in quantum physics. Imagine a spinning coin. Before it lands, it's in a superposition of both heads and tails. But the moment it lands, it becomes either heads or tails. The measurement in this case is the coin landing on the surface. Now, as we discussed earlier, that observing or making a measurement on the quantum system causes its wave function to collapse. Now, what constitutes a measurement? Is it a conscious observer or anything else? According to the classical view, some interpretations suggested that a conscious observer was necessary for the measurement and subsequent wave function collapse. This idea has been largely rejected. Now, according to the modern interpretations, a more widely accepted view is that any interaction with the environment that effectively records or registers information about the quantum system can constitute a measurement. This could include interactions with measuring devices, detectors, or even the surrounding environment itself. Now, what constitutes a measurement and how the wave function collapses is still a topic of ongoing debate and research. Now, there is a fundamental limit to our knowledge of these particles, which is the Heisenberg's uncertainty principle. The Heisenberg's uncertainty principle says that we cannot simultaneously know the momentum and the position of a quantum particle such as an electron. Now, although the Copenhagen interpretation is a widely accepted theory, it does have some limitations. One of the biggest limitations of the Copenhagen interpretation is the measurement problem. What constitutes a measurement? How does the wave function collapse so abruptly? These questions remain a subject of ongoing debate. While the Copenhagen interpretation provides a valuable framework, it's not the only way to understand quantum mechanics. Other interpretations, such as the many worlds interpretation and the pilot wave theory, offer alternative explanations for these perplexing phenomena. The Copenhagen interpretation, despite its limitations and criticisms, remains a significant milestone in our understanding of quantum mechanics. It provides a valuable framework for grappling with the strange and wonderful world of the quantum, while also highlighting the profound questions that remain unanswered. Hope this video has given you a better understanding of the Copenhagen interpretation. If you enjoyed it, please like, share and subscribe.